Right. Hello everyone, I am Swati and I am going to teach you Module 2 Inheritance and Interfacing in the course Object-Oriented Programming Systems with Java. Right. We will have a quick look on the contents of the Module 2. So these are the contents of Module 2: Inheritance, Method Overriding, Access Specifiers, Abstract Classes, Final Members, Object Class, Interfaces, and Package Fundamentals. So we'll be seeing the uh, every concept in code examples. So to start with inheritance, you might have learned the concepts of object-oriented programming systems in the module 1. So what are the object-oriented programming concepts? Basically, it starts with your class, then followed by an object, then your inheritance, polymorphism, dynamic binding, abstraction, encapsulation, and many more. So what is your inheritance? Right. Inheritance is one of the most important concept of object-oriented programming systems. So why are we going for an object-oriented programming language? Right, what is actually happening in an object-oriented programming language? We will try to simulate every entity in terms of an object. So what is an object associated with? Every object you take is associated with its attributes as well as behavior, right? That is your properties and a behavior. So the properties are termed as an attributes in the program, and the behavior is usually termed as the method or a functionality. Right. So when you are simulating the program in terms of the real world, when you are considering an entity in terms of a class and an object, then your inheritance deals with relating the objects. Why? Because in the real world, it is not just enough to simulate the program using an object. Objects will be related to each other. For example, I'm talking about a college and a student. So student is one entity. So you will be considering it as a class student and you will be placing the attributes as well as behavior associated with the student. For example, consider that I am dealing with a program where you need to calculate the average of the student marks in 3 subjects. So what you will be writing in a class? I'll be writing class. You can take the general attributes like student name, student US, and student department. And as far as my functionality is dealt, what is my functionality? I need to calculate the average of the student marks. Then what are the important properties you need to take? You need to take marks of the subjects. So consider it is 3 subjects. We will be writing marks 1, marks 2, marks 3, and so on. And associated with, other than reading the values and printing the values, the main functionality is to calculate the average, right? So I'll not be writing all the properties of the student. Student may have n number of properties, but I am not going to present n number of properties. You will be selecting clearly what are the properties required to perform the functionality, the actual functionality, right? That is your abstraction. That property is your abstraction. Now on the other hand, what did I say to you? I told you about college. College also will have its own properties and its own methods are the behaviors. Now, is your college and the student related with each other? Yes, your college and student is related with each other, right? So such type of relations, if you want to bring into your object-oriented programming, then you need to relate to objects as well. So your inheritance deals with relating two objects or two or more objects with each other, right? So what is an inheritance? Is a mechanism in which one object acquires all the properties and behaviors of the parent object, right? It is one of the main important part of the OOPS, and the relationship here is a relation, is a relation, right? And what is the aim of your inheritance is you can create new classes that built upon existing classes. So we'll be seeing with an example, right? Now you can see here, the main class is the shape class, and you are having rectangle and your triangle class, right? So in the shape class, what are the attributes you are defining? The first two, in the first one, you are defining the properties, and in the next one, you are defining the behavior. So the first one is height, which is a property, and the next one is width, which is a property. They both are of your double types. Next one, set values. That is, what is the value you need to set? It may be length and breadth and so on, any of the dimensions. Next, you are writing one property called get height and the next property as get width, which are returning your double, and the set values is not returning you anything. That is your void data type. So this representation in the program will be class shape followed by double height, double width, then followed by your functions. What is the function? Void set values of double comma double. The next one will be double get height, and you will be writing the functionality, and the next one will be double get width and you will be writing the functionality. So this is how you will be representing a class, a normal class. Now each and every object defined for that particular class will actually possess the height and width followed by these particular properties, because object is the actual runtime entity. Class is just a specification of this particular shape. But when you create an instance of your shape, then that particular instance will possess these properties as well as this particular behavior. Now, I am defining one rectangle, right? In the real world also, you know that rectangle is a shape. Next one, triangle. Triangle is also a shape. Now, can my class called rectangle and my class called triangle be related with your shape? Can I relate a rectangle as well as a shape? Can I relate a triangle as well as a shape? Yes, of course, you can define that one. Why? Because your rectangle also consists of the fields called height and width, and also you will be dealing with set values, you will be dealing with get height, and you will be dealing with get width. Similarly, the triangle also has height and width, and it can also have the behavior of set values, get height as well as get width. So now what you can see here is, apart from this, your rectangle is itself having one method called as get area. Similarly, your triangle is also having one method called as your get area. So now when there is a connection between these two, you call that this shape as well as rectangle are related with each other. Similarly, the shape as well as triangle is also related with each other. This is only an example of an inheritance. Which type of inheritance and whether it is possible in Java or not, we'll be checking in the further slides. So this is just an example of your inheritance. So I'll be considering this as a shape class, which is already having these instance variables as well as this behavior. Now, when a rectangle class is inherited from the shape class, it will possess all these properties which are there in the shape class will be acquired by your rectangle class as well, provided these all are public. Provided these all are your public data. If it is private data, again, this particular data cannot be acquired by your rectangle class, even though it is a subclass, right? So similarly, that is, I am talking about a class which is already defining some instance variables and the methods. Now there is one class called as your rectangle, which will acquire all the properties of your shape class, provided there is an inheritance relationship between these two. This is called as your parent class and a child class relationship. That is, I am actually building a relationship between these two classes. Similarly, on the other hand, I am having the shape again, and you are having a triangle. Triangle also will acquire the properties from the shape class, right? Apart from that, it is having its own method called as get area, right? Now, when you take your rectangle class and when you take your triangle class, they are acquiring the properties from the shape class. Now, what is happening here? What is the advantage you see here? If you are not placing any relationship between these two, you are missing one kind of relationship where you need to simulate in the real world. And the second thing is the main concept of reusability you can see here. See, if at all you are not defining this particular relationship between the rectangle and the shape, you need to define set values, get height, get width, height as well as width separately again in the rectangle class as well. Similarly, in the triangle class also, you need to define height and width separately. Set values, get height as well as get width should be again placed are associated in your triangle class as well. So what is happening here? I am defining this particular methods in the shape class and it is reused in your rectangle class as well as triangle class. Even height as well as width, which are the instance variables, are also been reused in rectangle and triangle class. So the main advantage of inheritance is reusability, right? So we will see the same thing here. Why use inheritance in terms in Java and the terms used? So the first one we will be concentrating is, we will come back to your method overriding. Whatever I said about the reusability is the code reusability. What do you mean by that? Instead of writing all these functions or the methods again in the rectangle or again specifying them in the triangle, you are going to reuse this particular methods in your rectangle as well as triangle class. That is what the advantage of your reusability. So the main advantage of inheritance is about code reusability. Apart from that, what is your method overriding? Right. Now, again, consider the same example. If at all you consider that your rectangle should also use the same method with this particular prototype, then it can do, that is, the set values of double comma double, which is returning a void data type, can be overridden by the rectangle class. Similarly, the triangle class also can take some method called getHeight, which is returning the double, and it can again write its own definition in this particular class. Set values of double comma double, which is returning a void, can be defined newly, that is, the functionality is different in your rectangle class, and your triangle class can also take some of the method and it can give its own definition. So this is called method overriding. A method which is same prototype is already defined by the parent class. Apart from that, what are you doing? My subclass is having, wants to take the same prototype and same method name, and it wants to give its own definition here. So this is called as method overriding, right? It is my child class or a subclass is going to override the functionality written by the parent class. This is overriding. So that is always allowed also. So your inheritance will be used for your method overriding as well as for the code reusability. Now, what are the important terms of your inheritance? Class, you know, class is a specification. For example, your class shape, this is specifying that the instance variables are, that is, the attributes are height and width, and the behavior of the shape is set values, get height as well as get width. So this is the first term. The next one is subclass or the child class. So which is your subclass or child class here? Rectangle as well as your triangle. These are the subclasses, right? The next one, superclass or parent class. Obviously, the superclass of our parent class of rectangle as well as triangle is the shape. So this is my superclass. These are the children classes, are the subclasses. And the last one is reusability. That is the basic aim of your inheritance is the reusability. Which reusability? Usually it is associated with code reusability. Now, the next one, we will jump to Java inheritance. So this is the syntax usually you made. Class, class name. Usually class name followed by methods and fields will be the normal syntax of your class. Now you'll be writing class, the subclass name. Extends is the keyword used to specify that this particular class is deriving the properties from the superclass. So for inheritance, you will be using extends keyword in Java. So I'll be writing class, subclass name, extend superclass name. So subclass is the subclass name and extends keyword is associated with the superclass name followed by the methods and fields. So your subclass can have its own methods as well as fields. Apart from that, what it is achieving, it is deriving the properties from superclass name also. That is superclass. So for example, this, what we'll be writing here, is your shape extending any of the classes here? No. So what will be the definition of your class? Class shape followed by double height, double width, followed by the methods. Void set values of double comma double, write the function definition. Next will be double get height and you will be followed by function definition. And similarly, your get width as well. But when it comes to your rectangle, what you are supposed to write? You should write class rectangle extends shape, followed by, if you are having its own methods as well as your behavior, you can embed that in the rectangle class. On the other hand, class triangle extends shape, right, followed by its own methods as well as attributes associated with triangle. Now what is happening here? Rectangle will write its own properties and methods, triangle will write its own properties and methods. By default, if these are public, then all these properties of the shape class will come and sit in the place of your rectangle attributes as well as behavior, as well as triangle attributes as well as behavior. So this is the syntax. So here what we'll be writing, class rectangle extends shape, class triangle extends shape. The only keyword you will be using is your extends keyword, followed by methods and fields of your subclass. Now, we'll be seeing what are the different types of inheritance.